Hey guys, we're still looking at characteristics of functions and graphs. Again, turn to your textbook. Your online textbook is lesson 1.2 and you can follow along. Alright, so we are going to define the average rate of change in context. Alright, so you've found the slope, you have found and interpreted the constant rate of change or slope for linear functions in context. Nonlinear functions do not have a constant rate of change, but you can compare the average rate of change between pairs of points on a curve. The average rate of change of a function over an interval is the ratio of the change in the function's values. So f of b minus f of a, that's basically saying your y minus y, to the corresponding change in x values, and we usually say x minus x, or usually we use y2 minus y1 over x2 minus x1. They're just using a's and b's. Don't let that confuse you. Alright, so the average rate of change is positive on the interval where b is greater than a, or f of b is greater than f of b, and negative on the interval when f of b is less than f of a. Alright, so the table models one day's predicted tide heights in relation to the mean low water level. Alright, so if you look at the picture here, you're going to see high tide goes to the top line and low tide goes to the where the water is currently, or a little above low tide it looks like. And then it says the tide range is what that is in between there. Alright, and they give you a chart with the time and height in feet. And then it says plot the data on a graph and sketch a smooth curve through the points. So you should pause the video, take a few minutes, and all you have to do is look at the chart and think of these as XY coordinates. If you want to think at 12 a.m. or as midnight, you can start that at 0. You can see I've already plotted the first 2 points here to get you started. So again, you can plot all of these points, and then we're going to sketch a smooth curve, and it's going to show you kind of the tide, or how the tide goes from high tide to low tide and back and forth. All right, hopefully you've taken a couple minutes and you've plotted those points and sketched your curve. I'm going to scroll down, and if you click this arrow here, it's going to show you what the sample graph looks like. Again, it's a sample. Everybody's may be just a little bit different because you're having to look at these. You know, you got 0 to 4, so 1's kind of in the middle here, and you got 0 to 4, so that means this is 2, so this is 1 point something, and you've got to just graph those points the best you can. So yours may be just a little bit different, but you should have sketched a curve similar to this graph. Alright, it says the tidal range is the difference in height between the consecutive high and low tide levels. Which observation can you make about the tide range at this site? Alright, so if we look at this, we can see that low tide is around 1 feet. And high tide, this is 8, so this is 10. It looks high tide here is about 9 feet. So it goes between 1 and 9. So if you choose one of these, and then we will answer it together. Alright, hopefully you picked the one that says the tidal range appears to be between 7 and 9 feet. So again, if you look, it goes between 1 and around 9 from those first 2 curves. And that's going to show you how we got that answer if my explanation wasn't sufficient. Kind of read through this and make sure you understand. Alright, again, pause the video, try to answer this question, and then we will look at it together. Alright, what is the average rate of change between the first low tide and the high tide following it? And the average rate of change of the second low tide and the high tide following it. So we can look at the graph, but the graph is a little bit harder because you don't know exactly what those numbers are, but if you look at the chart, you can see it's a little bit easier to see like the low tide and the high tides. So on the first one, you can see that looks like it's got a high tide here of about 8.66 and the low tide is at 1.19. So what I encourage you to do is just look at these as ordered pairs. So you're going to take this number, this ordered pair, and this ordered pair, and then find the average rate of change. So you can do that quickly, and then let's see what answer you get. Remember, you're going to do y minus y, and then x minus x. But remember, in time, well, this one won't be difficult, but in time, this would be times 0 at midnight. So 8 minus 0. All right, hopefully you got something very close to what I got, so about 0.93. So let's go back and see if that's one of our choices. And it is, so let's click on that. And then it says find the average rate of change from the second low tide to the high tide that follows it. So the second low tide looks like it occurs at 2 p.m. and the next high tide at 8 p.m. So go through and take these points. And again, you can tell your minimum and your maximum value. That's how you know that that's low tide and this is high tide. So use those points to figure out what your average rate of change is. All right, so hopefully you took your y values, 10.25, subtract 1.27, and divide that by 8 minus 2, and then you're going to get 8.98 divided by 6, and that's about 1.5. All right, so we can go back and locate the question again. And we're going to choose 1.5. All right, so again, the average rate of change is very similar to the slope formula. If you have questions, please look through the explanation here. It is very detailed. Hopefully it will make sense. All right, now a question, how does the average rate of change relate to the difference between each low tide level and the high tide level following it? All right, please enter your answer, pause the video, and when you're ready, please resume. All right, welcome back. Now we're going to move on to the next question. What is the average rate of change between 6 a.m. and 6 p.m.? Round to the nearest hundredth. All right, so again, I'm going to go back up to my table and I'm going to find 6 a.m. and 6 p.m. So 6 a.m. and 6 p.m. Again, you've got your graph, but the table is easier. So it says 6 a.m. and 6 p.m. So that's going to be this point. And 6 p.m. is this point. Now remember when you're setting it up, the y values are in feet, but the x values are in hours. So think about hours. There's 24 hours in a day, so you can't just minus 6 minus 6. First of all, you can't divide by 0, so you got to think through this one a little bit more. All right, pause the video and find the average rate of change, and when you're ready, come back. All right, hopefully you did 9.13 minus 8.57. And then you thought about 6 p.m. So you start at midnight, you go to 6 a.m. is 6 hours, noon is 12 hours, and then 6 more hours is 18. So to get this correct, you have to do 18 minus 6. When you do that, let's see what we get. So I'm going to get about 0.56 over 12. And that's about 0.04666. All right. Now let's go back and see what the question says. All right, round to the nearest hundredth. Okay, so we get around to 2 decimal places. So we are going to put this in as 0.05. Let's see, 0.05 feet per hour. Remember, it was 0.04666. 0.04666 rounds up to 0.05. All right, what does this information tell you? What do you think will be the average rate of change over even a longer period of time? Pause the video, go ahead and enter your answers, and come back when you're finished. All right, it says, what additional information would allow you to sketch a more accurate graph and compare average rates of change more precisely between high and low tides? All right, go ahead and pause it, enter your answer. All right. A sample answer would be maybe there's more points, and if there's more points, then it's going to be more accurate. So maybe instead of by the hour, they do it every half hour, and that way you would have more ordered pairs, which would make it more precise. But again, you may have something different, and I look forward to seeing what you have. If you have questions, please let me know.